Hello and welcome to the first episode of the IoT industry Bartalk with the companies SICK, Harting and B&R. My name is Madeleine Mikkeleit, the Managing Director of the IoT Use Case Partner Network. Our focus is the industrial IoT market and building partners and ecosystems for the future. We are convinced that the potential of the IoT technology can only be leveraged if first, the added value of all parties is clear, and second, there is a joint learning from projects and knowledge sharing. The focus is on the one big question. So what is actually the added value of IoT technology for you? Away from this product buzzword bingo towards real benefits. To answer this question, we discuss a use case from the practice. Today, on the example of KUKA robots providing new services for injection molding machines. I really feel like getting started. I hope you do too. These are our guests. Bernd Fiebiger, the R&D Principal Developer System Engineer IIoT at KUKA and user of the new IIoT technology, is convinced. Digitalization is a buzzword. The added value only comes when data from machine is made available for outsourced services. He demands we need manufacturer-independent communication, especially also for real-time applications. The Product Manager Industrial IoT Network Solutions at B&R Industrial Automation, Elmar Zimmerling, is convinced. OPCOA with TSN is the solution and the game changer for digitalization. He says, we are very close, the technology is there, we just have to implement it. Manfred Haberer, the head of integration solutions at SICK AG, is convinced. In addition to data availability, intelligent data interpretation is of high relevance. He says, up to now, it was hardly possible to interpret raw data at the important field level, but with smart sensor, it is. Joachim Finke, the head of product management at Harting, finds that this is precisely where connectivity plays a critical role. He says the requirement for interpreting data from the field level is that the sensors and actuators are connected to the network cost effectively and efficiently. Single-pair Ethernet is the answer here. And joining us later in the show, Peter Lutz, Director of Field Level Communications Initiative within OPC Foundation. He says our goal is to improve the standardization of industrial communication systems. That's our group for today. Let's get it started. So, Mr. Fiebiger, I want to start with you, just to get an idea how KUKA robots are used today. Can you give an example in which kind of industries you're active? And maybe you have an example use case for us, which we can use to discuss a bit deeper for the technology.
Yeah, KUKA robots are well known from the automotive industry, from joining processes like welding or gluing. Mm-hmm. But typically the robot is a very generic motion device which can transport parts when a gripper is equipped, or which can work on parts with a tool. But specific use case is just when a robot works together with an injection molding machine to take parts out of the machine while the process. And this is just a very fast process.
I see. So that's a very good use case to start with and to get an idea how the process could look like at the customer side. But now today we want to highlight the very value add of the new technologies customers are using today or maybe want to use in the future. So how do you especially use this technology or the digitalization today?
Yeah, just digitalization is just a buzzword because it's just nowadays everywhere. But for me, for machinery, digitalization means that I'm able to communicate with the machine. And so this is just a base to support in future with more services and this IIoT idea to bring the machines nearer together.
Yeah, perfect. So, okay, I understood this so far. So a KUKA service is, for example, then to provide the manufacturer maybe process data, maybe in molding machine, for example, insights about quality or defects per hour, for example, or even process real-time data to prevent collisions, for example, in this process. But why are you not doing this today already? Like, what's the challenge behind?
So currently, this technology is not introduced all over the field. call this the brownfield. And so in this brownfield, we don't have this converged networks, and using the right technologies like OPC UA, which we see as the technology of the future to solve these problems, to transport data to other layers. And so this is just the topic we have to solve, to use this vendor-independent standard, which everybody can implement, that all can use this data of the machines in the same way for the services.
Okay. So yeah, to get an idea, maybe for viewers who are not too deeply in these topics, devices and machines today all speak, as you just mentioned, like different languages. So for example, the robot tweets, the injection molding machine gives maybe smoke signs or something. And you have the camera sensor, which is giving like a Teams video call, for example. So now we want to make sure and to make sure that the manufacturer can connect and synchronize all these different data pools together independently of the machine or the devices. So let's listen to the OPC Foundation, what they are aiming for.
Yeah, OPC-UA is the globally accepted standard for supporting a secure, reliable, as well as manufacturer and platform independent information exchange, so to say, the language or the world language for production. It's good to see that companies such as B&R, SICK and Harting are working together to create added value for their customers.
Okay, mission understood. So if I now think further in the use case services for KUKA robots, we're talking here about more than just one data point, right? It's like masses of data in real-time applications which are transmitting through the camera, for example. If now the camera starts, for example, a Teams call as in the example, and the manufacturer want to synchronize the data from all these different pools, Mr. Zimmerling, how does it work today? Like, how do you do that?
I think first of all, this given example from the molding injection machinery together with the removal robot fits perfect to explain what determinism is and why it is needed. Because think about, you have to do it in a very high speed because you want to ramp up the productivity. And on the other hand, you can imagine that if you make any mistake in the correlation, in the coupling of the two controllers, one is the robot, one is the machine, then you can get a collision and you have to avoid it at any cost. So now for this, the time-sensitive networking, the TSN technology comes into play. Why it helps here very much? First of all, in a nutshell, it gives a major time clock to the whole network. So every participant gets a time referred to this master clock. And secondly, it guarantees that this time for this application is always the same and precisely on microseconds pace. Yeah. So that means that you can ensure that this virtual coupling, I call it, compared with a gearbox in the mechanical side, always is best done. And if you then combine the OPC UA semantic modeling together with this time-sensitive networking, then this is a game changer, because then you can really reach the last level, the last sensor, the last actor in the field level.
I see. So now the data arrives kind of simultaneously in the system and also in real time in the manufacturer system, right? How can we now interpret those data? Like I'm thinking now more of the sensor part. How does that work today?
Yeah, I think the smart sensors plays a major role in the digitalization and in all use cases which we are talking about. And our smart sensors generate so many more informations beside the pure process data, which are hidden in the sensor without a powerful network interface, which is standardized and which makes the engineering very easy and the data accessible for the new digital services, which are definitely needed. And therefore, I think OPC UA in combination with the TSN technology is the right technology to make this happen. And if we are talking about artificial intelligent as a use case for quality control in a molding machine, then of course you need a powerful interface to an IoT system, but you also need the real-time interface to the PLC, to the machine itself. And also for a simple trigger sensor, which generates much more information than the process data, the 1 bit, these data are also valuable for digital services like predictive maintenance. And in terms of cabling, I think the single pair Ethernet is really the game changer also for make informations and data accessible of small, smart, compact sensors.
So good point. The cabling, I want to learn more about that. You just mentioned a new buzzword, so single pair Ethernet. Mr. Finger, that's your topic, right? How does that work?
Exactly. So in the beginning, I would like to point out that OPC UA and TSN, they are both technology based on Ethernet communication. Means before we can collect data in the field level and analyze it with sensors, as just explained, we need to physically connect those devices to the Ethernet network. And you need to consider that Ethernet is a standardized system. Yeah? So for the factory automation, where this use case takes place, we have basically the 4-wire copper-based cabling for fast Ethernet, and we have the even 8-wire copper-based cabling for gigabit and 10 gigabit Ethernet. And you obviously see that this is a cabling which was tailored for office applications, data-driven, and not tailored to connect sensors. And exactly here is the point where single-pair Ethernet completes the story of OPC UA and TSN by connecting sensors, as the name says, and by just one single twisted pair of copper wires. And the advantage is obvious. So on the first point, we save a lot of copper. So it's a sustainable solution for the future. And secondly, to refer to the use case of Mr. Fibiger, a single pair cable offers a much better bending radius and also torsion. So means the reliability of the application in this use case is also increased. This is why we say from Harting, single pair Ethernet is the connectivity to connect end devices in the field, sensors and actuators to the Ethernet network.
Okay, perfect. Thank you very much. I guess we have all layers now from the use case. Maybe just make sure very quick, what is the main key takeaway for today? So I would like to start with you, Mr. Fibiger. What's your main key takeaway from today?
Yeah, it's very nice to see that a lot of people from different companies are running in the right direction and working on the same topics to make this all possible we have in mind. And I think this will shift the automation to a next level.
Okay, perfect. Mr. Zimmerling, what's your key takeaway?
First of all, I agree fully with Mr. Fibiger, but I want to give an appeal maybe to the community of us, of the industrial automation companies, both to the end customers and the machine builders, and not to forget maybe system integrators. Just make usage of these technologies because they are now, let's say they are not widespread today, but they are really mature enough to start the first projects and to make a design in for the next machine generation, which comes maybe in 5 or 6 years. So you have to start now, think about what to bring in, and the combination of OPC UA, of TSN, and also of single pair Ethernet. I think that will open next step of applications where we concentrate really on the use case and not on the backbone, on the connectivity. That must be self-explaining.
Yeah, perfect. Mr. Haberer, what's your key takeaway for today?
Yes, I think smart sensor data making accessible for added value, added customer value is really essential. And therefore, we need a seamless, powerful, and standardized network ecosystem. And I think the OPC UA in combination with TSN and single pair Ethernet is really the basic and will bring this digital services and digital world to a next level in the industry.
Perfect. And last but not least, Mr. Finker, do you want to add something?
Yeah, my outcome is that, as the colleague said, so both or all three technologies, they play together and benefit from each other. This is one point. And second point is that in this group, the companies we are sitting here, each company can contribute to accelerates this development. So Harting is providing and developing the IP20, IP65 connectivity for single pair Ethernet. It's then the task of BNR and SIG to design in those technology in their devices in order to, at the end of the day, enable companies like KUKA, or especially the complete big market of machine builders, to make use of all those three technologies.
Perfect. So thank you very much for this round, and looking forward for our next session. Thank you.
Thank you.
I'm glad you joined us today. In episode 2, we look at business models and new technologies currently being implemented by end users from the mechanical engineering. For example, from Trumpf, and another example is from the brewery side from Anheuser-Busch. Do you have any questions about controllers or the topic OPC-UA over TSN, please contact B&R. For smart sensors, please contact the company SIG, and for SPE, please contact Harting. All information and contact information are at iotusecase.com/Bartalk. So are you looking for a partner, or do you have general questions about the IoT technology? Please feel free to contact us directly. We look forward to learn more about your use case.